right, based on the problem description here, it seems like this graph is not Eulerian, but let's go ahead and verify. I see that vertex A has degree 3. Sorry, I'm gonna change the weight. All right, A is 3, as is B. So let me just move this down. As is C and D. E has degree 4 though. So these are my odd vertices. So that means I want to look for the pairings of all of them. So I could match A to B, and the least weight of going from A to B is 8. Here's another 8. That's going to be greater than 8. So 8 is the minimum, and I did that by going from A to B. I could have also said A, E, B, but we want the most direct one we can find. I need AC. AC has a weight of 5. That's greater than 5, greater than 5. So AC has a weight of 5, and that was through E. All right, also AD. A to D has a weight of 7 or a weight of 4. I'm going to pick the lightest one. Okay, now I need my missing ones. I don't have B to C. So B to C has a weight of 3, and that's the minimum. B to D has a weight of 6, minimum. And that was BED. And then I also need C to D. So C to D has a weight of 3, and here is the minimum. Okay, so now I need to cover all 4 of these vertices. So I would like to find 2 pairs that cover those 4 vertices. So I could look at AB and CD. That has a weight of 11. I could also look at AC and BD. That also has a weight of 11. AD and BC has a weight of 7. So these are my ways of covering all of my vertices. And this one is the one that has the least weight. So I'm going to select this one as my least weight. Those are going to form my multi-edges. So A to D I got by going AED. So I'm going to add that to my graph. So these are going to become multi-edges. So I'm going to draw them in as such. AE, ED. And then BC, which is just a direct connection, BC, that's also going to become a multi-edge. So I know somehow my graph is going to end up covering, let's highlight them. So every path plus every multi-edge. And somehow amongst these paths, amongst these edges, there's a circuit that I can walk. And to find the total weight of my closed trail, I'm going to end up adding all of these edges. So the weight of my trail is going to be 7. So I'm going to start at thinking about D. 7 plus 8 plus 3 plus 3. So I'm going around. I'm counting 3 twice because there's 2 edges here. Plus 6. Now I'm going to go into the center. 1, 1, 3, 3, 2, and 5. So I know it's going to have a weight of 42. And the question is, how can I get from D back to D? So I can try, if I start at D, I've got my 7, and then I can follow that over here along the 8. I can come up to 3, up to C. If I come then back down, C to B, now I can come up B to E. From B to E, I can keep going up, E to D, and then I can come back down to E, down to A, and then I can flip back around A to E, and then E to C, and now I can turn this corner and come back to finish my closed trail. So that's Chinese postman problem with a graph that has odd vertices.